Today we will be discussing the difference between kinematic and dynamic viscosity. Previous classes we discussed individually the definition of kinematic and dynamic viscosity. So these classes will be discussing the difference between these two. So at a glance, these two looks like simple, but there are numerous terms associated with them which makes a huge difference. So basically, it is a basic and most elementary fluid property, these two, kinematic and dynamic viscosity. So we have to make a difference in the tabular form. So first of all, with respect to the physical concept, kinematic viscosity, this is defined as the diffusivity of the momentum. To be precise, it explains how fast liquid is moving in a certain medium when certain amount of external force is applied. So it gives the diffusivity of momentum. What is diffusivity? Nothing but the spreading. Momentum, that it is product of the mass and velocity. So it is diffusivity of momentum, that is how the molecules of the liquid is spreading in a medium. Whereas dynamic viscosity, this is defined as the absolute velocity. It gives the information as the force required to move the fluid at a specific rate. So previous classes we discussed kinematic viscosity is nothing which represents nothing but which represents the quality of the viscosity. On the other hand, dynamic viscosity, it represents the quantity, that is, it gives the information as the force required to move the fluid at a specific rate. So next is mathematically how to explain kinematic and dynamic viscosity mathematically. So mathematically, this kinematic viscosity represents the ratio between dynamic viscosity to the density of the fluid, whereas kinematic viscosity represents the ratio between the shear stress and shear strain. So mathematically, that can be, that is kinematic viscosity, it is written as nu is equal to mu divided by rho, whereas dynamic viscosity, we know that shear stress represented by tau is directly proportional to the mu, some proportionally constant, or directly we can write down the tau is equal to mu into du by dy. So this represents the ratio between shear stress and shear strain. Next is with respect to the basic property, the kinematic viscosity is known as the most fundamental property. That is, it will not change with any physical effect. On the other hand, dynamic viscosity, it is a derived property. What is a derived property? Any property that is derived from some mathematical relation. So with respect to the density, kinematic viscosity is dependent on the density. On the other hand, dynamic viscosity is independent of the density. With respect to the unit, the most important thing is that unit of kinematic viscosity meter square by second in SI unit. In SI unit, the unit of kinematic viscosity meter square by second. On the other hand, unit of dynamic viscosity Newton second by meter square in SI unit. So based on the application, the kinematic viscosity is applied when inertia as well as viscous forces are dominant. On the other hand, the dynamic viscosity is applied when viscous force is only dominant. At the last, the kinematic viscosity represented by nu and dynamic viscosity represented by mu.